All right, let's keep rolling with section 3, or chapter 3, section 3.2, the graph of a function. So last section, 3.1, we learned about what a function is. Now we're going to graph them. So we could have a situation where we have a lot of information here. We have a year and a price. And so this is definitely a function because every single input, the year, would have a specific output, the price. And so we could graph it like this. And so if we move along here, this is going to be a function because it follows one very specific rule, which is the vertical line test. So objective 1, identify the graph of a function. A function exists if it passes the vertical line test. And so what that means is if you took your pencil and laid it down vertically, that pencil could only touch one point on the graph at any given time. So both of these curves would be functions because your vertical line would only touch those curves in one point. Both of these would not be functions because boom, boom, we're touching it in two places. Boom, boom, we're touching it in two places here. All right, so these two would both fail the vertical line test. So take a look at problem 15, see if you can figure out which ones are functions and which ones are not. Okay, second objective, obtain information from or about the graph of a function. So we're going to be given this function. Now we can't assume that this repeats. We're going to say it stops here, starts here. All right, so let's take these questions piece by piece. What are f of 0? This means, remember, if x is 0. So if x is 0, what is y? 4. If x is 3 pi over 2, y is 0. And if x is 3 pi, boom, y is negative 4. What is the domain of f? All right, so it runs from 0, the smallest x you can find, until, what's the biggest x you can find? 4 pi. Square brackets because it's touching those two things.
Hi,
Solid
do you have
basis.
a key for that room?
Yeah. 1 second. Sorry about that. I had to open up the door. Miss Barbara was sick today. Sub didn't have a key. Okay, moving on. Where were we? What is the range? We need to figure out what the y values are. So the lowest y I can find is down here. That's negative 4, touching, all the way up to, what's the highest vertical point? Positive 4. Okay, and let's list all the intercepts. It touches the y-axis there. So one intercept would be 0, 4. It touches here, pi over 2, 0. It touches here, 3 pi over 2, 0. It touches here, 5 pi over 2, 0. And one more, 7 pi over 2, 0. How often does the line y equals 2 intersect the graph? Here's the line y equals 2. Let's take a look. Once, twice, thrice, 4 times the line y equals 2 intersects the graph. For what values of x does f of x equal negative 4? All right, so that's when does the y equal negative 4? Once, twice. So pi and 3 pi. Last question, for what values of x is f of x greater than 0? So when are the y values above 0? We're above 0 from 0 to pi over 2. Now pi over 2 would be a parentheses because at pi over 2 we're not greater than 0, we're touching 0. And then from 3 pi over 2, right here, all the way over to 5 pi over 2. And then again from 7 pi over 2 all the way up to 4 pi. And we touch 4 pi there, and we stop. Those are the x values for when y is positive. Okay, try similar things on problems 9 and 13. All right, let's try this one more time. Obtaining information about the graph of a function x over x plus 1. Is the point 1, 1/2 on the graph? I don't know. Let's plug it in. We'll plug in 1 for x. 1 over 1 plus 1. That's 1 over 2. And that is 1/2. So this is an absolutely. Yes, it is. If x is 2, 2 over 2 plus 1, or 2 over 3, what is f of x? It's 2 over 3. So what's the point on the graph? 2, 2/3. And if f of x equals 2, what is x? Okay, a little more tricky. 2 equals x over x plus 1. Let's multiply by x plus 1. Equals x. So 2x plus 2 equals x. And we'll subtract the x to the other side. So we'll have x plus 2 equals 0. X equals -2. So if x is -2, then y ends up being +2. And that's the point on the graph. 25 is yours to try. Okay, average cost. The average cost, and it's C with a bar over this, of manufacturing X computers per day is given by this function. Determine the average cost of manufacturing 30, 40, 50 computers in a day. This seems like a lot of work to do by hand. Sounds like a great problem for the calculator. Let's plug it in. Y equals 0.56 x squared minus 34.39x. Let's move this over. Plus 1212.57 plus, and in parentheses so we don't get lost on our order of operations, 20,000 over x. And so let's go to our table, which should already be in ask mode. All right, if we have 30 computers in a day, we get 1351.5. That's the average cost of making one of them. What if we made 40 computers? Okay, the average cost goes down a little bit. 50 computers, average cost, goes back up. Interesting. So the average cost looks like it bottoms out somewhere around 40. Let's go ahead and graph this. And if we come back here, between 0 and 80 for x. So we want to do a window where our x min is 0, but a little smaller than 0, so we can see 0. -5 is good. X max a little bigger than 80, and so we can go from there. And let's go, our y min is -5. From our table, probably going to want our y max to be somewhere bigger than 1233. Really even bigger than this. 1233 would be our minimum down here. So let's go back into our window. Our y min, let's make this 1200. And let's go bigger than that. How about 2000, just to be safe here. And let's go ahead and graph. Okay, there we go. We can see the bottom. It's going to bottom out right there. And so, create a table with table start 1 and delta table 1, which value of x minimizes the cost. I'm going to cross this out. I don't think we're going to want to start with a table start of 1. We're probably going to want to start with a table start closer to, I would say, 30 over here. So table set, let's make it 30. Counting by 1. We'll do auto. And so we can see when we get our smallest value, 55, 47, 40, 35, 33, 31. Oh, back up we went. 41 would be our lowest cost, 1231. All right, so which value of x minimizes the average cost? 41 would minimize your average cost. Now we could do that on the graphing calculator also when we graphed it by calculating the minimum. And so we'll say left, we'll go right, and then we'll guess right at the bottom. And so the true minimum is 41.2168, but remember we can't make a percentage of a 0.27 computers. Have to make a whole computer, so we would say 41. Okay, 31 is yours to try. All right, that's it for 3.2. Just a quick summary there. Graph of a function is the graph of the collection of points. Vertical line test tells you whether or not you have a function. Any questions? We'll see you in class tomorrow.